Welcome back with another video on TryHackMe.com. This is Zahin Nazir and we are doing DevSecOps. So in today's videos, we're gonna do the dependency management, which is coming under security in the pipeline. But before we move on, let's track our progress. We are on track, especially when I increase the end date, which is 31st July 2024. As you know from the previous video, we had this set at 2nd July 2024, but we were not able to do it because it was taking a lot of time to complete the practice that we had done in our previous video. So let's get into it. The path progress is 38%, and the next achievement will be mother seekers once we will reach at this point here. Okay, so let's start our dependency management. Okay, so streak rate हमारा दोबारा से 0 चला गया क्योंकि कल हमने नहीं किया था, लेकिन we are consistent. We are uploading one video every day. And guys, if you haven't subscribed, please subscribe and follow along. If you like the video, please give it a thumbs up, and if you have any suggestion, please put it in the comments below. Also share this video with others, which will help us build this community. We are targeting to have at least 1000 subscribers by the end of August 2024. Okay, let's get into it. Dependency management. Learn about the security concerns regarding dependency management in the automated DevOps pipeline, and it will take around 120 minutes. Admin will be able to do it in 4 videos, hopefully. Okay, so let me minimize it. Okay, once it is ready, we'll show it. Okay, task 1 introduction. It is very uncommon in the modern times to find an application written completely from scratch. Yeah, it is uncommon. Mostly you already have a template which will you use. It will already have, most common code that you have written for other applications. So reusability of the code is a big concept in software development. So that statement is right. Furthermore, writing it completely from scratch is probably a bad idea, since you will most likely introduce vulnerabilities by trying to reinvent the wheel. That is very true. Instead, modern applications make extensive use of libraries and software development kits. That is true. That assist with the basic and sometimes complex features of the application, allowing the developer to focus purely on the key features and functionality of the application. That is very true. Since I've been doing software development for last 13 years, so I can pretty much give you that all of these statements that we have read now are true. These libraries and SDKs are called dependencies, since our application depends on them. While dependency makes our lives a lot easier, they have to be surely managed, since they now form part of overall attack surface of the application. Of course, man, of course. In this room, we will learn about security concepts associated with dependency management and show how a specific dependency management issue can be exploited by an attacker. Sure. This room will teach you about the following concept: security principle of dependency management. Dependency management थोड़ा सा हमने टच किया था पिछले रूम में. आप इसी प्लेलिस्ट के अंदर आप जाएंगे तो कुछ जो पिछला मॉड्यूल हमने जो कवर किया है 7 सीरीज के अंदर, वहां पे आप देख सकते हैं. ये थोड़ा सा हमने कवर किया डिपेंडेंसी मैनेजमेंट का. Securing external and internal dependency, we also covered this one before, but I think in this room we'll do some practical dependency confusion attack as well. Answer the question below. I am ready to learn about dependency management. Yes, of course, we are. Okay, so we are back to streak 1. Okay, let's move forward. Task 2. What are dependencies? The scale of dependencies. While you may think that you are writing an incredible amount of code when you are developing an application, it pales in comparison to the amount of code that is actually performing actions for you in various dependencies that you include. Let's take a look at a simple Python example. Okay, so Python example is we are importing numpy, and then we are doing something in the numpy. For example, numpy.array 1 2 3 4 5, and then we are declaring numpy array 6 and assigning it to y. The first one assign it to x, and then print x into y. That means we are taking each element from the x and multiplying it with y and printing the output. So let's see how they explain it. In the example, we are using numpy library to create two arrays, then multiply them with each other. We effectively wrote about 4 lines of code. However, just that first line, import numpy execute a underscore int underscore dot py file in the background that contains 400 lines of code with an additional 30 imports. Ooh. With a conservative estimate of 250 lines of code per import, this means that our one line of code has executed roughly 8,000 lines of dependency code. Oh, it's just huge, man. It's huge. If you extrapolate this data, you are probably only responsible for 0.01% of all the code in your application, and dependencies make up the remaining 99.99% of the code. This is why dependency management is vital for the security of any pipeline or software development life cycle process. Sure, that is very true. Let's move on. Dependency management. Dependency management is the process of managing your dependencies through your SDLC process, DevOps pipeline. We perform dependency management for several reasons. Knowing what dependency our application uses can allow us to support it better. Of course, अगर हमें पता है कौन सी डिपेंडेंसी है तो वो जो अटैक सरफेस है उसको मिनिमाइज करने में ये हेल्प कर सकता है. We often want to version log dependency to improve the stability of our application, since newer version may add new features or deprecate features that our application actively uses. Yes, we can version log it, but it really depends upon the stability of the dependency itself and also the support structure around it. So for example, if you're using .NET 6, its support is already expired. So you always go for the latest LTS version. For example, .NET 8, which support is still there, and they are actively monitoring and patching that SDK. Okay. So it really depends on the version and stability and the support structure around that dependency. So they didn't put the support around here, but it's okay. I just explained it to you. You can build golden images that already have all our dependency installed. Meanwhile, we can perform faster deployment cycle. Yeah, this is true. I think since they uses the images could be like VM images or container images, which already have all the dependency installed. You just need to deploy your application and it will just work fine. And it also include, for example, if there is any security check or anything, any scanning that you need to do on top of these golden images, they would have already been done, and you don't need to worry about the dependency security at all. Okay, so companies do it a lot to minimize the attack surface and do their due diligence before even the application is deployed. When new developers are onboarded, we can help them set up their development machine by installing all the required dependency. Yes, okay. We can monitor the dependencies we use for security issues to ensure that dependency are upgraded with the security fixes as needed. That is very true. So if you have golden copies, that means these golden copies, if there is any patch, you will just patch it and you will use that newer version and golden image for all the new deployment. And in the meantime, you can also if you're using container or something like that, you can also plan the migration to bring the source code to the newer version of your VMs or containers. Okay. Most large organizations use tools for dependency management such as JFrog, Artifactory, or Azure Artifact. We briefly touched upon this in previous rooms. Go check it out in 7 series of this playlist. This allows the organization to manage all of their dependencies from a central location and allows dependency management to be integrated into our DevOps pipeline. That mean, for example, if there is a central location where you are managing all the dependency and somebody is checking in the code, they will always use the local centralized location version of dependency. Okay. So for example, if you have everything in the Azure artifacts, all the NuGet packages are there. So once the build server will build your code, it will always take the version store in your environment rather than going to the NuGet package website and picking it from there. Build server then agent can make requests to dependency manager to be provided with the dependencies when the application is being built or deployed. That is very, very true. What do we call the libraries and SDKs that are imported into our application dependencies? Of course, I think dependency or dependencies. Okay. Maybe dependencies. Yeah, okay. We are good. We are good. Okay, we are on to task 3, external, internal and external ones. Internal versus external. While the dependencies can be classified using various classification for this room, we will focus primarily on one classification, namely the origin of the dependency. Hence, our dependencies can be classified as external or internal dependency. External dependency, we briefly touched upon this before, right? But they may give us more detail and examples here. And external dependency is one that has been developed and maintained outside our organization. Usually the dependency are publicly available. Some are free, but some can be paid for SDKs. Some example of popular external dependency include any Python pip package that you install from the PyPy public repositories. Yes, jQuery and other publicly available node package manager npm libraries such as Vue.js and Node.js. Paid for SDK such as Google's reCAPTCHA SDK that can be used to integrate CAPTCHAs into your application. Yeah, it is not paid for until you reach certain limit. But if you need, for example, there is a lot of traffic on your application and you need to buy a larger number of quota, then this is paid. Otherwise, you can use it freely. Okay. External dependencies include almost any dependency that we ourselves have not created. This means that someone outside our organization is responsible for maintaining the dependency. Of course, internal dependencies. An internal dependency is one that has been developed by someone in our organization. These dependencies are usually only used by applications that we develop internally in our organization. Some examples of internal dependencies include an authentication library that standardizes the authentication process of all our internal developed application. Yes, a data source connection library that provides application with various techniques to connect to different data sources. Yes, a message translation library that can convert application messages from a specific format to one that a different internal application can read. Yeah, so these are all internal dependencies. So if you have a development background, all of these dependencies would make sense. So if these doesn't make sense, it's okay. Internal dependencies are usually created to standardize an internal process and ensure that we don't have to reinvent the wheel every time we want that same feature in another application. That is very true. Code reusability hence is the way to move forward. Since we develop these dependencies ourselves, we as an organization are responsible for maintaining these dependency. Of course, external versus internal dependency. The origin of dependency does not necessarily make it better or more secure. It depends really. Because if you are downloading something from Microsoft, you will have certain level of trust that Microsoft have done their due diligence to make sure that it is secure. But however, based on the origin of the dependency, the attack surface is different. Meaning we will need to take different security measures to protect each. In this room, we will talk about these security measures for both external and internal dependencies before practically exploiting one of the security concerns internal dependency have. Okay. Would an authentication library that we created be considered an internal or external? Internal, of course. We just read it. I'll copy and paste it here. Yes. Answer is correct. Would jQuery be considered an external? External, because we are downloading it from external resource. Okay, we are good. Let's move on to the task 4. Until now, everything is moving forward very quickly. I'll start the machine first. As you can see, there is .NET MVC, Vue.js, React, Google APIs, reCAPTCHA, and K2. Almost, I have worked with all of them, almost. As mentioned before, external dependencies are one that are hosted, managed, and updated by external parties. External dependencies are an interesting part of SDLC to secure, since we are not directly responsible for security of dependency. Since if we want a secure application, we will have to manage these dependencies. In this task, let's take a look at some of the security concerns with external dependencies before executing a supply chain attack. Sure, public CVEs. ये बड़ा अच्छा concept है. Let's see. The team that develops external dependencies are not robots who don't make mistakes. They are humans just like the rest of us. This means there may be vulnerabilities in the code that they have written. The issue, however, is that these vulnerabilities will be publicly disclosed, usually as common vulnerabilities and exposures, CVE. Once the developer have created a patch, while this is good practice to ensure that the developers create patches for us, it is a problem since it means that our specific version of their dependency is now vulnerable to an issue that is advertised to attackers online. So if CVE is available for the dependency for the same version that you are using, that means there could be an issue. And since CVE is publicly available, and if some attacker try to attack your application, that means they will be able to do that successfully, because everything is available online. That how to exploit this and mitigate the issue. As such, we must react as soon as possible and patch our dependency, but this is easier said than done because we are using external dependency, and that means if there is any issue, they need to fix it rather than we, because we are not responsible for maintaining the external dependency, and that means we are dependent on the speed on which they will fix the issue rather than fixing the issue by ourselves, right? Because we are not maintaining that dependency internally. We may have version locked a dependency for the stability of the application, so upgrading to a new version means we will first have to determine whether such an upgrade could cause instability. That is very true. The problem gets even worse when you start to talk about dependencies of dependencies. It is perhaps not the SDK that you are using that is vulnerable, but a dependency of the SDK that is. Since the dependency has to be updated, we will also now need to update our SDK. So usually dependency कोई इतना बड़ा रिस्क नहीं है, लेकिन डिपेंडेंसीज की जो डिपेंडेंसीज है वो रिस्क पैदा करती हैं. सो यूजली क्या होता है, जब डिपेंडेंसीज में कोई मसला होता है तो यूजली उसको सॉल्व कैसे किया जाता है, बाय रिलीजिंग अ न्यू वर्जन ऑफ द फर्स्ट डिपेंडेंसी. इन आवर केस इट इज SDK. So they are giving us an example to look at. Log4j is a prime example of how bad this can truly get. Log4j is a Java-based logging utility. It was used in almost every application that was developed in Java. This led to several products being vulnerable when a vulnerability was discovered in the dependency. You can look here, the full list of the impacted products is a lot, I mean, in thousands maybe. We had looked at this list before, so if you want to just click on it and take a look, we'll move forward. The list got so big, more than 1,000 products, that they had sorted it alphabetically. Depending on the discovered vulnerability, it will impact the risk associated with the specific dependency. Since Log4j's vulnerability allowed for remote code execution, this is the primary goal that a hacker want to do. If we can do remote code execution, we can do pretty much anything. The impact was significant. If you would like to explore this issue more, have a look at this room. Okay. So this is a solar room, and it will take 60 minutes to do it. They are basically explaining how to do this: proof of concept, exploitation, persistent detection, bypasses, mitigation, patching, and others. Oh, it is created by John Hammond. Awesome, man, awesome. He's a very good creator, by the way. Okay, and it is 73 days ago. Okay. We'll take a look once, whenever we have some time to do that. But in the context of current room, we'll just move forward. Okay. Supply chain attacks. Even if dependencies do not have any vulnerabilities and are kept up to date, they can still be leveraged to attack systems and services. As more and more organizations are becoming security conscious and making it harder for an attacker to compromise them, attackers had to become more crafty. Instead of trying to attack the application directly, which has been hardened, an attacker instead targets one of the dependencies of the application, which may have been created by a small team that does not have such a large security budget. These indirect attacks methods are called supply chain attacks. Okay. So instead of attacking directly to a target, we target the dependency that the application is using. Okay. So if that is the way we are working, the hackers are working, that means this is a called indirect attack method, and we also call it supply chain attack, right? Because you are attacking the supply chain itself. One advanced persistent threat APT group, namely the Mega Caught group, was notorious for performing these types of attacks. Some highlights of their actions. Okay, it is interesting stuff. Compromising the payment portal of British Airways. Online portal led to compromise of credit cards of customers and a fine for BA of $230 million. Ooh, it's huge, man. Compromising more than 100,000 customers' credit card by embedding skimmer in various payment portal of various applications. Ooh. Compromising more than 10,000 AWS S3 bucket. See, AWS S is the big name, and embedded malware in any JavaScript found in these buckets. Awesome. I mean, British Airways, and then you have AWS. So the Mega Cart group showed that we do not really have to target an application directly. It is far more lucrative to compromise a dependency used by the application. These supply chain attacks are even more effective since a dependency might be used by several applications, meaning the compromise of a single dependency could lead to compromise of several applications. Yes, if it is an external dependency and it is globally used, then the impact will be far much reachable. There are several ways to compromise dependencies, but by far the most common is when dependencies are insecurely hosted, allowing a attacker to alter the dependency. This would be For example, an S3 bucket that has word writable permission configured, an attacker would abuse this permission to override the hosted dependency with malicious code. Of course, फॉर एग्जाम्पल एक DLL है और वो आपने S3 बकेट में होस्ट की हुई है, लेकिन वो होस्ट आपने ऐसे की हुआ है कि उसके ऊपर आप री राइट कर सकते हैं राइटेबल परमिशन, वर्ड राइटेबल परमिशन के साथ कन्फिगर है। इसका मतलब है कोई भी बंदा पब्लिकली इसको चेंज कर सकता है। तो इन दिस केस हम क्या कर सकते हैं, एक DLL नई DLL जो है वो एक हैकर जो है वो डाल सकता है S3 बकेट के अंदर, जिसके अंदर मिलिशियस कोड उसने डाला हो, राइट। So it is pretty much, you can do exploiting supply chains. Let's try to perform a supply chain attack. We will simply simulate a supply chain attack, start the attach machine and the attack machine and navigate to this URL. Sure. I will copy this. I will show and view. Let me close this one and open the Firefox. Let me navigate down to the actual steps that we need to perform. Okay, here it is. Let me paste and go. I have done this. Using the Firefox on the attack bar, once the machine is active, you will see that this is a simple authentication portal. Be aware, we can continue. We need to embed a host name entry to simulate the internet-facing S3 bucket. Perform the following command on your attack machine to inject the hostname into the etc host file. Okay, so they already have a right IP address, so let me do that. It is CDN. Okay, let me open this and paste. It is done. Once ejected, you can refresh the page and should see the dependency loading if you insert the code of the application. Okay, wait. I'm refreshing it, but nothing is happening. Right? Okay. Right click, view source, page source, yes. Okay, you will see that it pulls the dependency from cdn.tryhackme.log. Yes, it does. Let's inspect this dependency a little more. Open a link to that dependency and it should allow you to download a JavaScript file called auth. Okay, so I clicked on the link, it opened the file. As you can see, it is doing something. Basically on key press is equal to enter. Okay, dot login submit dot click. This is our shared authentication library. It includes a really cool function that will auto submit the form when a user presses enter in the password text box. Of course. Taking a closer look at the code in this library, it seems to add a JS event that will monitor the password text box for keystrokes and automatically submit the login form if a user presses enter. With no real vulnerability in the code, let's take a look at where the dependency is being hosted. So dependency is being hosted here. If you go back one step in the request to cdn.tryhackme.loc944 libraries, we can see that this seems to be a S3 bucket. Okay, wait a moment. Let me open this one here. List bucket result. Yeah, it seems to be a bucket coming from AWS. There is a library, max keys, content, last change, size, storage class. Okay. A quick way to see if the team perhaps misconfigured S3 bucket to grant word writable permission would be to try a simple put request like this. Okay, put mean you are writing something. So let's do that in curl. Either you copy paste or I will just write it down to just memorize what we are doing so we can use it later on in our hacks test.js, and then D is the message, I think, testing word writable permissions. Okay, let's see. Uh no URL specified. I specified the URL. Right. Okay, let me copy paste this. Maybe I'm doing it wrong or misspelling it. I'll copy paste, enter. Yeah, it is done. Running this required, it seems that we get an HTTP OK. We can also see that we have the ability to download this file. Okay, let me copy this link and try to open it in Firefox, which is here. Yeah, we are downloading this file. That is true. That means we are able to write this particular file. This is looking positive for a supply chain attack. At this point, there are several different ways we could go about exploiting this word writable S3 bucket to cause a supply chain attack, but we will keep it simple by embedding a credential skimmer that would send us the user's credential when they click submit. Okay, download the auth.js dependency and modify the code to look like this one. Okay, sure. I will download this one. Let me refresh. Okay, wait. Let me remove the view source and download this file, which is here. Okay, so it root. So let me open a terminal here. Okay, and this and modify the code to look like this. Okay, so if we have either we can use Vim or we can use mousepad. Let me use mousepad because this is what I like. Mousepad. It will give you a GUI to execute and do the same steps that you do in, for example, TextPad or Notepad or something like that. Okay, it is reading. 90%. Hopefully it will be done in no time. Yes, progress 50%, 75, 88. And we are about to be done. Yeah, it is almost done. Yes, so let me open mousepad. It is auth.js. So this is the file. So what we're gonna do is we're gonna replace it with this one. Okay, let's see what happens here. But I can see there is something thm_ip. I don't know what we need to put it here. Okay, let's see. Code explanation. Make sure to modify the THM IP to the IP of your TryHackMe VPN or the attackbox IP. The attackbox IP is 10.10.138.252. So let me do that here. 10.138.252. But before I do anything, let me further check that. Wait, it's not working. Wait, let me make it full screen. So we'll be able to do more on the same. Okay. So All right. So let me see the IP address. Let me see if we are using the right IP address here. So this is QLAN, and this is our IP address, and there is no C. Okay, there is a CI/CD as well, and the IP address is 10.50.42.235. I don't know if this is what we are looking for. Docker 0, and then two other one. So let me use the ENS5 IP address, which is also listed here. But if this will not work, we'll go with the CI/CD one. Okay. So let's continue. Where is our mouse pad? Here it is. I put the IP address already. Let's see what else we need to do. This is what we have done. Okay. Taking a closer look at the code. This is what we have done already. Yeah, okay. The injection is fairly simple. Once the user pressed enter to submit their credential, we make an XHR HTML, XML HTML request to our host, where the username and password are the target or embedded as parameter in the request. You will notice some lines of code for the creation of a sleep function, then the using set sleep function before the button is clicked. This is to ensure that the malicious XHR request has completed before the page transition occur. Otherwise, a modern browser would stop the request from occurring. Let's override the existing auth.js file with our embedded skimmer. Yes, we can do that. Upload dash file. So not this one. Here. So let me save it first. And now I can close it. Make it a little bit bigger. Here is curl. We are uploading the file dash upload dash file and .js. It is uploaded. We could host an entire server to receive the keystrokes, but let's keep it simple with the Python server. Sure, python.m http.server will host it on 7070. So let me do that here. Okay, we have done that. We can test if our skimmer is working by using the website ourselves. Complete the form and press enter after typing in your password, and you should intercept the credentials. Okay, let's do that. It is here. Let me make it a little bit bigger. Here we go. Password is username is admin, password is admin as well. Let's submit the query. We did that. Welcome to admin, your password is admin. Wow. Okay. And let's see if we received any. We did not. We did not receive anything. Wait a moment. Because I just want to see if our request did get executed or not. So I will do one thing. I will refresh it so the newer version of the auth is loaded. How can we see that? We can see that by going to debugger. There is a library, and here the newer version of it is loaded, right? We can verify that, and let's try it again. Admin. I think now we will be able to get this this one as a call back. Where it goes? Yeah, here we let me make it a little bit bigger. As you can see here, we receive the user, super user, and password is also a super user here. Super secret. User is super user and password is super secret. Password 123 add. Okay, this is what we have found. If it works, you now just need to wait for someone to authenticate. Give it 5 minutes and you should intercept credential from an actual user. Once you have intercepted the user's credential, use them to authenticate to the website and recover the flag. Okay. So user is super user. I will type it. Let me just copy the password and let's authenticate. I'll go back. This super user admin, it is admin user, and I'll copy paste the and we are able to get the flag here, guys. Awesome. I put the flag here, and let's continue. What else we need to learn? Okay, use them to authenticate. Yes, we have done this and it works perfectly. Defenses. It is difficult to defend against the attack stage against external dependencies since there are so many and new vulnerabilities are found daily. However, excuse me, there are certain things that we can do it to limit the risk. Make sure to update and patch dependency on a regular basis. This would include emergency patching of dependency if a sufficient serious vulnerability was discovered. Dependencies can sometimes be copied and hosted internally. This will reduce the attack surface. Sub-resource integrity can be used to prevent tampered JS libraries from loading. In the HTTP, include the hash of JS library can be added. Modern web browser will verify the hash of the JS library, and if doesn't match, the library will not be loaded. So yeah. So for example, once you include the link to the library itself, you can also paste the hash about which was computed on the library itself. So if somebody have changed something, the hash will not be the same. So the modern web browser will be able to reject it. Okay. Which advanced persistent threat group is notorious for their supply chain attacks? It's Mega Caught. Okay, Magicot. Okay, it is Magicot, guys. Apologies. What is the password of intercepted credential? Here. No, not this one. On a moment. This is the password. I'll copy it and paste it here. And we are good to go, guys. Congratulations, we have completed task 4. That is it for today. Once we come back, we'll move on to the task 5. And thank you very much for joining me on this journey, guys. If you have any question, please put it in the down below in the comment section. And if you haven't subscribed, please subscribe and give also a thumbs up to this video. And I will see you in the next video. Thank you very much and bye.